Today what I want to do is go over the warm-up that's in your packet on page 17, and it's taken from page 90 in your textbook. So you might need to refer to that to be able to see the numbers clearly on a couple of the instances. I'm going to go through and do all the work and explain it. So it would be good if you tried to do it on your own and then looked at the video, or start it with the video, stop the video, see if you can do the next one by yourself. So use it as a teaching example. Okay, so I'm going to share my screen with you now. Okay, there we go. Okay, so this is different notation. This is not prime. Okay, this is your Leibniz notation. So the reason why you know it's Leibniz is because it's saying d dx. So what the format is, it'll say d dx of some function, and that's going to equal the prime of that function. Okay, that's how this works. So that first one is hard to read. It is x to the 8. So let me see if I can write that on top of here. So this is x to the 8. Okay, so its derivative you can very quickly take. That's just going to be equal 8x to the 7. So notice your answer comes along one line. If I was doing prime notation, so for 49 with prime notation, I would have had to have two lines. For example, I could have said y equals x to the 8. Then I would say y prime equals 8x to the 7th. Okay, I would not say y equals x to the 8th equals 8x to the 7th. That would be bad. Okay, so now we're good with that notation. Let's go on to number 50. So 50, because they already brought it up for you as a negative exponent, you can directly take the derivative. So that's going to equal, using Leibniz notation, equals negative 3x, go more negative, to the negative 4. Okay, and that's a good answer. Okay, 51 is x to the 3/4. So using Leibniz notation, you would say equals, bring down the 3/4, and then you would have it be x to the negative 1/4. So I'm using the power rule. I'm using it directly. I'm not writing out all my steps. So you should be at this point now. If you're not, I would just do the extra work someplace away from the problem and then pop your answer over there. Okay? Okay, the next one also is easy enough to do. Using Leibniz notation, I would say that function, so this Leibniz notation is saying the derivative with respect to x of x to the negative 1/3 is, okay, so negative 1/3 x to the negative, you're going to go another negative 3/3, so that's negative 4/3. Okay, keep going. Now they changed the notation. So I'm going to box off, this is Leibniz notation. The next is dy dx. Okay, dy dx, so dy dx is just like y prime. It's just like f prime of x. They're all the same category. Okay, so it's saying find dy dx if y equals 1. So you would then say dy dx equals 0. Okay, that's that notation. Okay, and this is why I'm doing the video, because I want to make sure that the notation is all straight in your mind. Okay, 54, find dy dx if y equals x to the negative 4. And so you would say dy dx equals negative 4x to the negative 5. Okay, so if they asked you for dy dx, you should not say y prime equals or f prime of x equals. You should use the notation that they're asking for. Okay, dy dx, if y equals x, and this is the 1/5 power, 1/5. Okay, so down below here, I would say dy dx equals 1/5 x. 1/5 minus 5/5 is -4/5. Okay, and the last one is tricky, but you have to think about what this is. Okay, so this says find dy dx if y equals x minus 1/3. So what is that? What I would do if I was you, I would rewrite this. So I would say, oh, doesn't that mean that y equals x/3 minus 1/3? Okay, if I don't see it yet, I'm going to do it again. Y equals 1/3 x minus 1/3. Therefore, dy dx equals the slope of a line, which is just 1/3. Okay, so you have two different notations. One is Leibniz, and the other is dy dx, which is in the same category as y prime and f prime of x. Okay, so I hope that was clear. I also want to do 57 because 57 is a good graphical application. So let's look at that right now. Let me help clarify what this is saying. So this says y equals x/3 plus 2, and that's functioning as the tangent line. So it says consider the curve y equals f of x in figure 15. Find f of 6 and f prime of 6. Okay, so to find f of 6, that means that you're saying, okay, if 6 is my x, what is my y? This is f of 6. So take the equation that you know, which is y equals x/3 plus 2. So it's going to equal, the x will be 6/3 plus 2. So that's going to equal 4. So therefore, f of 6 is going to be 4. Okay, they're just asking you for the y value if the x value is 6. So don't overcomplicate that. The next one, they want to know what f prime of 6 is. So you have to take your tangent line and take that first derivative, because you know that that first derivative, well, actually, let me take that back. When you look at your tangent line, don't you have a derivative? So you already have a derivative. What is that? So look at it very carefully, and what are you seeing? That where your x is 6, if you go up, this is the slope. If that's the slope, you know that your slope is just 1/3, because isn't it true that this equation is 1/3 x plus 2? All right, that equation has the same slope as the tangent line does when x equals 6. That's why I can just take the slope without doing anything else, and I'm set to go. Okay, so that slope is 1/6. Be able, 1/3. Be able to clearly distinguish and have a strategy for when they ask you to find the function evaluated at an x value, as opposed to the first derivative of the function evaluated at an x value. They are two very different things, so make sure you are certain what you're doing. Okay, so this is the video for this page in your review packet. I'd like you to write this out and to post it. Okay, so post it to this assignment. There's a second assignment this day as well, so you'll have 2 postings. Thank you for listening.